Okay, let's start out this lecture by reading what it says in the pink or red box there. A baseball team consists of 15 players. How many starting lineups can the coach make from these players? Or look in the green box. 6 Gillette College students were trying out for the bowling team, but only 4 students are allowed on the team. How many different bowling teams are possible? Well, these are examples of problems that require the use of permutations and combinations to solve these problems. These are found in sections 2 and 3 from chapter 11 in your textbook, and there are definitely going to be problems like this on your My Math Lab assignments and on your chapter 11 test. You'll find out that using a calculator really speeds up the process in solving these. And let's learn about permutations and combinations. One thing to remember, and probably the most important thing I'm going to teach you today, is you have to decide whether the problem requires permutations or combinations. Well, here's the difference. On permutations, order matters. POM, permutation order matters. So if you remember the word pom-pom, that kind of helps you remember POM. POM, permutation order matters. For instance, if you are a baseball coach and you have to make a starting lineup, it matters what order you hand that lineup into the umpire or the scorekeeper, because you have a batter that bats first, another one that bats second, and then third, and then cleanup, etc. Whereas if you're like choosing a set of students to be on a student council, that order doesn't really matter there. If you're just coming up with 5 committee members, let's say, out of a class of 8, you have to choose 5. It doesn't matter what order, so that would be an example of combinations. So permutation order matters, combination order doesn't matter. And the book teaches them a section at a time, and I'm just going to mix them together so that you learn to distinguish between the two. Okay, there's a formula you use for permutations, and that formula is right here. N factorial over n minus r factorial is the formula you use when you figure out that order matters. So you're going to use permutations. So a permutation of a set of n distinct objects taking r at a time, and we'll talk about that n and that r in a second. Basically, n is going to be the bigger of the two numbers, r is going to be the smaller of the two. So if it was a baseball team with 15 players on it, your n would be 15 for the 15 players, and your r would be 9 because you have 9 people chosen for your batting lineup when you turn in your batting lineup. Whereas combinations, it's the same exact formula, but notice there's one extra part to it. On combinations, you have an extra r factorial in the denominator. So permutations is just n factorial over n minus r, the quantity factorial. Whereas combinations, when order doesn't matter, it's n factorial over r factorial times the quantity n minus r factorial. So, and here's where you find them on your calculator. And by the way, I checked, even a little $12 or $13 calculator like the TI-30X has, you'd click on the PRB button for probability and you'll find permutations and combinations there. So on this graphing calculator, the permutations is number 2 there, which says NPR, and the combinations is option number 3, which says NCR. So here's permutations, here's combinations. And you get there the same way we learned how to get to the factorial button last lecture, by hitting the math button and then going over to probability. And there you go. So let's start doing some problems using permutations and combinations, and like I said, the important thing is to decide what should we use. Let's read the first problem here. 6 Gillette College students were running for student council. How many different ways should they be appointed for president, vice president, secretary, and treasurer? So they're not just going to be on a committee where order doesn't matter. We have to decide who's going to be president, vice president, secretary, and treasurer. So order matters on this, because we have to specifically say who's going to be first, who's going to be second, which is vice president, who's going to be third, which is secretary, etc. So because order matters, we use permutations. And we have 6 students to choose from, and we're going to choose 4 of them. So we could either say 6P4 or P64. You see it different in different textbooks. I believe our textbooks use this notation, but I'm not positive. Either way, all you're going to do is this. The formula says to put 6 factorial on top and 6 minus 4 factorial on the bottom. So 6 factorial, you remember, means 6 times 5 times 4 times 3 times 2 times 1. 6 minus 4 is 2, so we put a 2 factorial, which is 2 times 1 on the bottom. Well, the 2 and the 1 both cancel, so we're left with this as our answer. So 6 times 5 is 30, times 4 is 120, times 3 is 360. So our answer is going to be 360 possibilities. There's 360 possible ways of choosing our officers. Now let's find out if I did my math right there. I'm going to grab my graphing calculator and I'm going to go 6 and then math, and then I'm going to cursor over to probability and down to option 2 because we want permutations, and then I need a 2. So there we go. 6p2 is 30. So what did I do wrong? Oh wait, it was 6p4. I didn't do anything wrong. I put it into my calculator wrong. So let's do this again. Down to permutations, which is option 2, and then we're choosing 4 officers, not 2 officers. So there we go, 360. There, I was worried there for a second. So if you have a graphing calculator or scientific calculator, you don't have to go through all of this process over here. You can just put that into your calculator and come up with the answer. But it's very important to know, are you using combinations or permutations? We used permutations on that problem because order mattered. Now let's read the next one. 6 Gillette College students were trying out for the bowling team, but only 4 students are allowed on the team. How many different bowling teams are possible? Well, notice it doesn't matter what order students are on the bowling team. You know, Billy and Donna is the same as Donna and Billy on a bowling team. Doesn't matter what order. So we're using combinations, not permutations. Well, the combinations formula is still 6 factorial there. It's still 6 minus 4 factorial down here, but you might remember there was an extra r factorial right there. So what we have going here is 6 times 5 times 4 times 3 times 2 times 1 on top. And then my 4 factorial is 4 times 3 times 2 times 1. And then I also have a 6 minus 4, which is 2. 2 factorial is another 2 times 1. So here we go. All of this right here cancels, right? And then this 2 is still on the bottom, so I have 30 on top and 2 on the bottom. 30 divided by 2 is 15. So there's 15 possible 15 possible bowling teams I could choose, taking 4 students out of 6 students. Now let's double check that on the calculator. So let's grab the graphing calculator, and I'm going to go 6 and then over to math, go over to probability, go down to combinations, or I could have just clicked on 3 and hit enter, and 4. So that's 6 people trying out for the bowling team. We're choosing 4 of them. Order didn't matter, so we used combinations, and we get 15. Perfect. Okay. So there's one example of permutations, one example of combinations. I did it by hand and by calculator. I'm doing all the rest just by calculator because I'm guessing most of you students will be using calculator on these problems. Okay, a baseball team consists of 15 players. How many starting lineups can a coach make from the 15 players? This is definitely permutations, because when you turn in a batting lineup, as we discussed before, order matters. So we're choosing 9 players out of 15 to start on the baseball team. So I'm going to grab my calculator and I'm going to put in 15, math, probability, permutation is option 2, 9, so there we go, 15p9. That's a big number. And what I'm going to do is, I know I'm going to forget it. So 1 let's see, what do we have here? There's a comma, there's a comma. So it's 1,816,000,000. 1,816,000,000. So let me get that written down. 1,816,000,000. Now, because of my short memory, now I can go back and get the rest of it. So 214,400. 214,400. That's an awful lot of possibilities for a starting lineup. That's why you always have parents-matic coaches right there. They never think they get the right starting lineup. Okay, this is different. A basketball team consists of 12 players. How many starting lineups can the coach make from 12 players? Well, in basketball, you just send 5 people out on the court to play all at once. They don't go out one at a time like in a baseball batting lineup. So this is a combination problem. Order doesn't matter. So it's 12C5 because we're using combinations. So let's go 12 and then probability. Let's go to the math, over to probability. Combinations is option 3, 5, and 792 possible starting lineups. So you can see it makes a huge difference whether you're using permutations. Gives you way more options, doesn't it, or way more starting lineups than combinations does. Okay, I better get moving here. In poker, a person is dealt 5 cards from a standard 52 card deck. How many different 5-card poker hands are possible? Well, this is combinations because you're just going to look at your 5 cards. They aren't in any certain order. So it'd be 52C5. And I'm guessing that's going to be a pretty dang big number. 52 combination C5. How many different poker hands could you have? About 2,598,960. So 2,598,000. I think I had that number right, but that's how many poker hands you could have, 5-card poker hands from a standard 52 card deck. Alright, let's go down here. The number of permutations of n items where p items are identical, q items are identical, r items are identical, and so on is given by that formula there. That seems like a difficult thing, but it isn't. What it's saying is this: how many distinct ways can the letters in the word Mississippi be arranged as an example of that? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 letters in Mississippi. And the S repeats itself 4 times, so I have a 4 factorial there. The I repeats itself 4 times, so I have a 4 factorial there. Is there anything else that repeats? The P repeats itself twice. So to find out how many distinct ways can the letters in Mississippi be arranged, you do 11 factorial over 4 factorial, 4 factorial, 2 factorial, and we did one like this in the last lecture, and I'm running short on time, so I won't actually complete the problem. But remember, you need to put that in parentheses when you put it into your calculator in order to get the right answer. The last thing we're going to look at is, and I'm not going to do all of these because I've got about a minute left, but read this: a company has 7 seniors and 5 junior officers. A committee is to be formed. How many ways can a 4-officer committee be formed so that it's composed of? Okay, let's go down to this one. We need 3 senior officers and 1 junior officer, and since order doesn't matter, you're going to use combinations. So what you have is 7C3 times 5C1, because we have 7 seniors and we're choosing 3 out of those seniors, and we have 5 juniors and we're choosing 1 out of those juniors. So you're going to figure out that number and multiply it by that number to get your final answer. Okay, so you just let the calculator do that work, and you can actually type that entire expression into your calculator to get the answer. Okay, good luck on MyMathLab and on your test on these permutation and combination problems, and thanks for watching the lecture. Bye.